Hello, my name is Karen Deck, and I'm the president of Save Our Home Society, which was formed in 2017 in response to TimberWest's announcement of their logging plans on Mounts Holmes and Good above the community of Youbou. Since then, we've stood firm in opposition to logging and steadfast in our desire to protect watersheds, preserve fish and wildlife habitat, prevent damaging slides, and promote ecotourism. It is our honor to have Dave Polster here with us, whose entire career has been dedicated to ecological restoration. The title plant ecologist doesn't begin to describe his qualifications nor his work on the ground, developing innovative bioengineering treatments for a variety of difficult sites, including Pacific Forest Product slides, TimberWest slides, Campbell Group slides, Interfor Clayoquot Sound slides, among other restoration challenges. So rather than talk about his many achievements, which would probably take up our entire time together, I will just invite Dave Polster to share some of his expertise with us today.
Well, thank you very much, Karen, and we'll look at some of the issues associated with harvesting as it's currently practiced on slopes like Mount Holmes and stuff. So one of the things to think about is that water doesn't run across the ground in natural forests. It's in streams, and those are fed by springs. But what we've done when we harvest our forests is we've destroyed this water holding capacity of the watershed, and now we suffer the consequences. Large areas have been cleared of forests, and you should notice that the roads and skid trails remain on the forest for many, many years, and that actually adds to the problems, because a natural forest will suspend a third of the water that falls on it in the leaf canopy of the forest. So we get the roads and ditches on roads, compacted surface, and the question comes up, how can we regain those ecological services that have been lost? Well, if we look back at the forest, we can see how that could happen, including benefit us all, including the salmon. So why is this? Well, there's a whole bunch of things in a natural forest that move rainfall into the near surface groundwater zone. So you see things like sword ferns, funnel-like shape that moves the rainfall into the near surface groundwater zone. And moss on rocks creates conditions that prevents runoff. Mossy ground cover prevents soil erosion and allows the rainfall to soak in. Things like salal on the West Coast. If we didn't have salal, we probably wouldn't have a West Coast anymore, because it would have washed away many, many centuries ago. But look how the water channels down to the stem, down the stem, and into the groundwater system. Even pretty flowers, and we think of the erythroniums, the pink fawn lilies, funnel water into the groundwater system. And in addition, these natural forest processes have been operating for millions of years, when a tree turns over in a forest, and they do that, whether they make a sound or not is another question, which I won't answer, but they make a hole in the ground and bring up great big chunks of soil. As that turned over tree root clump decomposes, it leaves a big mound on the forest floor, gets revegetated, and eventually it becomes a mound on the forest floor. And that's why the forest floor is not smooth. And so natural forest floors are rough and loose and allow water to soak in. And these free natural surfaces are often lost when a forest is harvested, especially, you know, the mossy covering on this rock was lost. You see water running, you know, evidence of water running across the surface. We know there's a problem with hydrology, because that should not happen in a natural forest. Things like hillslope interception, where you have the road going across the hillside and the near surface groundwater all of a sudden becomes surface water. And so you get, you know, a big channel of surface water running down the road. And you can see how this happens in forest roads. And, you know, the compaction on the center of the road is preventing the alder, and these are alder trees, from moving into the center of the road, right? So we see the alder providing nitrogen to the adjacent trees, no nitrogen in the adjacent cut block, but again, the compacted road surface is preventing the water from soaking in. So we, you know, less compacted shoulders, more compacted road. And, you know, if we think of ecological processes such as alder as a cover crop for Douglas fir, it makes the Douglas fir grow better. And so we get alder coming in at this former log landing site, and it's established, but it's not growing as well as the alder in the adjacent areas because the ground is compacted. And that we lose these ecological services, and then we end up having problems like landslides. And so we get these open slope landslides. There's no road up there that failed. There's just the open slope landslide came down across a road. There was a road there, and creates a problem. So we need to have big bridges because we end up with flashy flows. They carry sediment. So we get large quantities of sediment moving into our rivers and streams. And the excess sediment causes avulsions, that is the breakdown of the stream bank, and problems with infrastructure. You may recall that Duncan flooded in 2009. This is totally related to timber harvesting in the watershed. And, you know, lovely flooding in Duncan with problems for everybody. Of course, the immediate solution was to build dikes. But if you look at dikes, they don't actually work to prevent flooding. What they do is they squeeze the water into a smaller area. And so you look at things like New Orleans and Katrina, the hurricane, or New York and Sandy, both of those caused flooding because of the dikes. And so our dikes, we need to restore the watershed and the floodplains. I mean, why is it called a floodplain? It has to flood. So we look at the problems of associated with this, we see it costs everybody money. And we lose the ecological services that are associated with the forest, and bridges blow out, especially in an ecological reserve. Or we get gravel deposits in a golf course. You know, very, very simple problems, but the solutions have yet to be implemented. So we look at the lots of money being spent. We get trees and gravel and everything. Look at things like forest fire resilience, resistant to forest fires. So is that site resistant to forest fires? Or this site? Well, it turns out natural processes have evolved over the many years to create conditions where you've got deciduous species over top of conifers, and that actually makes the conifers grow better. That's the way our forests have evolved. There's a bunch of reasons for this, but that I won't go into, but it happens all over Western North America, at least as far as I've studied. So build forests that are resilient to fires. So you look at Fort McMurray that nearly burned down a few years ago, and what we see coming up are the deciduous species. And these species will sucker up from the balsam poplar and aspen and stuff and rebuild the forest. This is a site near Campbell River where we've got the deciduous over conifers. It makes the conifers grow better. This was a mine site that I restored, and up by Campbell River. Really good leader growth of the conifers. And so we get very good growth. We don't spray the alder. We encourage it, because what it does is it makes the conifers grow better. And you can get very good growth of conifers. And you can actually measure the growth of the conifers. So you get, with the alder, you get better growth than without the alder. I mean, you still get good growth, but it's not anything like with the alder. So how can we deal with hazards in forest situations? And you can see the cracks in the edge of this road. It's the Hillslope failure. We can make it rough and loose, like the compacted site. We make it rough and loose, like the forest floor. And it creates conditions that allow all sorts of vegetation to move in all by itself. This was an old road on Salt Spring Island. And we can look at how natural processes have solved all these problems millions of years ago. So what is the hydrology and biological impacts of excess gravel? Well, it's not good for salmon, for sure. And so how can we use these natural processes to solve these problems? So we look at landslides. What are the filters that are preventing recovery? Well, it slid down to the compacted till underneath, and so there's nothing going to grow on that. We look at the forest roads that crisscross this area. the spraying that eliminated the deciduous species and the landslides that are starting. Excess sediment from slides and industrial activities are causing stream instabilities. So what can we do? Well, we can address road inadequacies initially to avoid disasters. That's going to happen there. And immediately remediate the chronic conditions. This is a compacted road surface that is showing evidence of water running down the surface. Alder is an important species that I mentioned before, and very important for restoration. So we can use these treatments to deal with soil bioengineering, things like landslides. So what to do first? Well, we got to get rid of the hanging failures waiting to happen. Otherwise, we're going to have problems with landslides and sediment sources. This is the Glacier Park landslide that closes the Trans-Canada Highway periodically. And rather than trying to trap the material at the bottom, I've been working on this landslide and suggested that we work all the way up to the bedrock that's failing and treat that, because the landslide is just getting bigger and bigger. And so what we look at here are the species that are coming in. What do we have? Well, we've got balsam poplar coming in on the landslide, telling us what we need to plant. We look at across the valley, the Griffith Landslide, and again, balsam poplar coming in around the edges. Up near Fort St. John, same, a landslide up there, same species, balsam poplar, right, coming in. Balsam poplar across the valley. And it's these sorts of clues that give you an idea as to how to restore sites. And so this was a landslide up by Rocky Mountain House, balsam poplar trees starting to come in. The Frank Slide on the BC-Alberta border. All these yellow trees are balsam poplar. And you can see the balsam poplar, how it's created conditions for nobody brought in topsoil or anything. This is rock from the Frank Slide. And the conifers are growing. Ancient landslide on Kootenay Lake. Again, balsam poplar. This is the Johnson's Landing landslide that came down in 2012, killing 4 people. Came right through the center of town, right through town. I was asked to help with the restoration of it. So I worked with the community, and one of the things that we see when we looked at the landslide is that balsam poplar was still standing in the middle of the landslide. No other trees were standing there. The Douglas fir and stuff had been wiped out. I mean, it was battered and took a bit of abuse, but it was still standing there. So I said, okay, let's plant the deposition zone with balsam poplar cuttings so that we'll have some protection when the rest of the landslide goes. I grew up. I mean, this is the leader growth. And they're coming in all over the landslide. So we see the balsam poplar, and western red cedar creating that condition with the deciduous over conifer that has evolved to create good growth of the conifers. And, you know, very, very good successional patterns that have dominated in Canada. And balsam poplar coming up all over the landslide. My friend Osa Thatcher. And so you see the landslide has recovered. We did live staking down here, but we didn't do anything up here. And it's all recovered with balsam poplar. I wanted to show you an example of how you can restore large sites. This happens to be the Heber River Dam. It was west of Campbell River and Penstock. Compacted road surface with stuff growing on the edges, as you saw before. Successional patterns that are happening in the region, well, balsam poplar, alder, all coming in. So we get, you know, I mean, this is up by Campbell River, so we're getting red alder coming in to beat the band. This is on the material that had been dredged out from behind the dam for years. And eventually the conifers come in and they grow really well. So we made the sites rough and loose, scattered woody debris, and basically increased the topographic heterogeneity. But that's a fancy word for rough and loose. We had some sword ferns because the local First Nations wanted to get involved in the restoration of the dam site, collecting the sword ferns from adjacent areas, along with the root systems, which brings in the soil mycorrhizal components, the microscopic components to the site. And so we scattered these around. I think we totally moved about 1,200 sword ferns and got them planted. So if you look at the dam area, the dam was right across here. What you see, keep your eyes on those two trees because they show up again, is that in 5 years, we've got effective restoration of the dam area. None of those trees were planted. We just planted sword ferns. You know, so we're ready for winter. Part of it was in Strathcona Park, and BC Parks was concerned about the restoration of the area, so I did a bunch of transects to show that things were working. This was their transects. We scattered woody debris, and what you can see with the woody debris is birds perch on the woody debris. They poop out the seeds of fruit-bearing plants that they've been eating. So things like salmonberry and thimbleberry and stuff. And so those seeds then become part of the flora that's reestablished. So we get, you know, fruit-bearing plants in 98% of the 50 plots that I did. We've got alder coming in, even between the rocks of the riprap. So the alder's showing up naturally. It actually locks the riprap in place. It holds the riprap in place. So we've got alder coming in the riprap. We've got the alder in the dam area. And Lots of alder over the years. Year 2, I had 8,500 stems per hectare. Year 3, 5,400. Year 4, 6,200. And year 5, the last year of assessing it, I had 6,900 stems per hectare of alder coming in, with conifers in 98% of the plant plots and 84 other species. Only the sword ferns were planted. And the conifers grow up really well. And more recently, I've taken a couple of pictures in the wintertime to show the growth of the conifers. Notice that bent tree grows up. This is one of the penstock right of way. And growing up. I mean, trees take a while to grow, so they grow up slowly. And eventually, within 5 years, they're well over my head, and we've got conifers coming in underneath. And so 84 different species, which means that the ecosystems that have established have a high degree of ecological resilience. And this is going to become important in the face of climate change, is making resilient ecosystems. None of the plants except the sword ferns were planted, and we saved on the order of $15,000 a hectare. I mean, including showy species like this columbine. Would you know where to plant a columbine? Grow up, and got a log there, and if you look closely, there's 3 or 4 different conifers coming up beside the log. These are alder growing up. The leaf litter from the alder, of course, introduces nitrogen to the system, which is one of the reasons the conifers grow so well. And it basically grows up. Conifers coming in underneath. That's a few years later, the conifers are bigger. It's amazing things grow. And over the years, you get an increase in species composition. You've got conifers, different species, 5 different species in the 50 plots. Got a total cover of 54%. Very good cover of alder. And we'll leave it there for questions. So.
Thank you so much, Dave. It makes me think again that old saying, when one tugs at a single thing in nature, you find it attached to the rest of the world. And the most important thing is we have to listen and look at how nature solves problems.
Exactly.